Attraction and phase change is a pretty difficult concept to think about abstractly, so I'm going to do my best to try to explain it as best as possible so that you all can at least get the basic understanding of it before we continue moving forward. So, essentially, all substances have some sort of attraction between the molecules. So, if you were to zoom in as far as you can, so that you can see the molecules, these molecules within the substance will have some sort of attraction to one another, whether that's a weak, a medium, or a strong attraction. Now, if a substance has a weak attraction, it's going to phase change a little bit quicker because kinetic energy can penetrate it a lot more. In higher temperatures, we're going to achieve more kinetic energy. So if we increase the temperature, let's say starting at a solid, and we start increasing the temperature a little bit more, it's going to take less higher temperatures, or we're not going to need more kinetic energy to break this type of attraction for it to phase change. Whereas if the molecules have a strong attraction to one another, we're going to need more kinetic energy, meaning higher temperatures, to turn this into a liquid. Now, their attraction to one another within the substance never changes. A weak attraction is always going to be a weak attraction, and a strong attraction is always going to be a strong attraction. Now, it just depends on how much kinetic energy is put into these two substances that's going to essentially create that phase change. All right, so I'm going to test this out. Essentially, what I'm going to do is I'm going to put this plate of M&Ms, which is made out of chocolate, and Jolly Ranchers, which are both starting at a solid. Okay, both of these are solid. And I'm going to put them in the microwave for 30 seconds. Now, they're going to be in there for the exact same amount of time and under the exact same amount of heat at the same time. Once we come back, we can talk a little bit more about the different attraction levels that each one of these had. Okay, so after about 30 seconds in the microwave, this is what came out. We can see that the M&Ms are still solid, okay, and the Jolly Rancher is completely liquefied. Now, what this means is that the molecules in the Jolly Ranchers had a weak attraction to one another, which is why it was so easy for it to turn into a solid and phase change. Whereas the M&Ms probably had a little bit of a stronger attraction to one another, which under the same conditions, under the same heat, did not phase change. So we just saw essentially how a solid can become a liquid once enough kinetic energy is put into it, right, via higher temperatures. Now, because the Jolly Ranchers had a weaker attraction, it melted way before the M&Ms did, which probably maybe not necessarily have a strong attraction, but have a stronger attraction than the Jolly Ranchers. So that's how it works as a solid. Now, as a gas, because there's already a lot of kinetic energy within a gas already, that means that a lot of kinetic energy needs to be taken out in order for that to turn into a liquid. Now, as for gases, it's quite different than starting off as a solid, mainly because things with a higher or stronger attraction is not going to need as much energy being taken out before there's any type of phase change that we see. So I can't really show this to you like in a video with real objects, so I decided to go back to the simulation. So we have substance A, which is the highest level of attraction. I've turned on the kinetic energy and it's at its highest, right? So right now, whatever substance this is at its highest point, which has turned into a gas. Now, if we're going to be transferring energy out so that it can become a liquid, Okay, you don't really need to take out a whole lot of energy in order for you to start seeing it starting to phase change, right? We're at 291 degrees from 500. Now let's say, I'm gonna go back. Okay, now let's say we're trying something with a low attraction level. Okay, there's a lot of kinetic energy, much like in the last substance, right? It's at its highest point. Now with this, if we're going to be transferring out energy so that we can see a phase change, okay, even at probably where we were at when we saw a phase change in substance A, we're still seeing that it's a gas. Okay, we're at 144, still a gas. We're at 20 degrees, still a gas. Okay, finally kind of starting to see the molecules buckling down, I guess. And then now there's hardly any kinetic energy. They're all kind of settling towards the bottom. And we're at around negative 181. So far to sum up, sorry, this is a really ugly picture. So far to summarize what we've just done, in solids, or if we're starting off as solids, substances with the weaker attractions will melt first, as you saw with the microwave and the M&Ms. In gases, substances with stronger attractions will condense first, meaning that it'll phase change, turn into a liquid first.